The rock cycle. Every first year geology student, or basically if you want to take it as a complementary course to another, should I say, major such as physics or chemistry, you should learn the rock cycle. Now what the rock cycle means is you have three different types of rocks. You have sedimentary rock, metamorphic, and igneous. Now, basically the rock cycle says this can become this can become this becomes this becomes this. You know, they can interchange with each other, basically. Through weathering, erosion, compaction, and cementation. I live by the beach, so there's a lot of material that I see cemented, such as coquina rock and other types of sediment. It's really fascinating stuff if you want to go to the beach and collect some of these things. It's really beautiful little specimens you can find on the beach. And you have metamorphic rock melting, becoming magma, cooling fast, becoming igneous rock. Heat and pressure igneous rock becomes metamorphic rock. Heat and pressure. So basically, you have heat and pressure and compactation, weathering, erosion. This is the rock cycle, okay? This is basic geology. Now, all geologists, they learn this. They say, oh, well, this is how the rocks are formed. What they don't realize is they also make an invisible wall that separates their studies from other studies. Now, if you were paying attention to a previous talk, I don't really want to erase this, but I have to. If you're paying attention to a previous talk, I had gone over the astronomy wall. Now, I'll go over it really quickly for you guys right now. So you have, these are thermodynamic phase transitions. Crap, I forgot to spell M-O-D-Y-N-A-M-I-C. Phase transitions. Trans, I'll just put trans there. Okay, you have your plasma, okay, then you have your gas, and you have your liquids, and you have your solids. And you have your solids to your liquids, okay? So you have phase transitions. Now, the astronomy wall was you have a plasma, such as a plasma in a star, okay, becoming gas. This is where the wall was earlier. Remember the astronomy wall? Or astrophysical wall. Now, a lot of cosmologists, they like to say phase transitions only occur during the Big Bang pseudoscience event. I say pseudoscience because that's what it is. But you can ignore Big Bang nonsense. That's absolute crap. That's 19th century nonsense. What you should pay attention, though, is a lot of astronomers, they take plasma and they keep it as plasma. And then the gas, solids, and liquids, these are what planets are comprised of. But as you know, in the theory of stellar metamorphosis, plasma cools and becomes gas, which means I have gotten rid of this invisible wall that astronomers can't seem to wrap their heads around. That's the astronomy wall. Now, with geology, they have a wall too, an invisible wall that compartmentalizes their studies. And if you could tell from the rock cycle, I don't know why I erased that, just have to draw it again. Now the rock cycle, I don't know if you can tell, but where would the rock cycle be in this? Really, where was the rock cycle? You had magma, and you had, which was liquid, and you had solid rocks such as sedimentary rock, igneous, and metamorphic. So basically, you had liquids and you had solids. The rock cycle only goes over these two phases. Meaning, the geology wall is actually right here. It's between gases and solids and liquids, those counterparts. This is where the geology wall is. This is where they compartmentalize and they block off all studies having to do with gas depositing in solids and gas condensing into liquids. And of course, higher temperatures and pressures, meaning the rock cycle ignores when stars were mostly gaseous. And the astronomy wall, as we went over earlier, is up here. So literally, you have then completely blocking off the gaseous stages of stellar evolution. You have geologists and geophysics down here, and you have astronomy and astrophysics up here. And this group of people, they're compartmentalized, or just mental. Sorry. And you have your geology wall compartmentalized down here. Now, it will be a great challenge for any of my listeners, audience, to say, hey, geology, they need to talk to the astronomy people. Now, that would make sense, would it not? Because according to this theory that I'm drawing up, that is very time-consuming and mentally draining, all stars, okay, cool and die. So you have, here's your basic Hertzsprung-Russell diagram. Okay. Now, I drew this line right here because this is where the spectrum drops off. You can't see the star once it hits this area. This is the magnitude. And this is the color spectrum. Okay? This SMA, plasma, okay? This is where the star is a plasma, but then it transitions to gas right here. Remember my earlier talk, you had two walls. You had astronomers staying up here, and then geologists down here, okay? And then they both ignore gas. They both ignore this part. So it should be no wonder why astronomy can't figure things out. And also should be no wonder why the geology department can't figure things out either. Why is the interior of the Earth still hot? Radioactive decay? I highly doubt that. Earth is a still cooling star. Okay? It's gone through all stages of stellar evolution to get where it is right now. It's very old. This should be good news for the geology department, if anything. It means when you pick up rocks off the ground, you're studying an ancient star. It also should be good news for the astronomy department because they can study a star. It's right below their feet. They can literally deduce how stars evolve by studying the Earth and reverse engineering it. Now, I don't know if they're up to the challenge. Maybe they're not. I don't know. But the challenge is there now, and that's what I'm taking on. Hopefully people can see where this rock cycle and phase transition kind of thing go hand in hand. And hopefully people see that both geology and astronomy are compartmentalized, and they're both in their own little bubbles. If they just push those bubbles together, they would have more of an understanding of the world around them, and they would be better off. But, you know, that's up to them.